Welcome back, scholars. For week 5, I'd like to walk through two examples with you of how we can graph quadratic equations. So if you scroll to the bottom of the document, I have one example that we'll walk through where it's already graphed, and then we'll do one example of when it's not graphed, when you need to be able to interpret the equation and find the information that we need. So the key for this week is some vocabulary words that we have covered already, some that will be new to us. So since we have quadratic equations, quadratic means basically that we have something that's going to be to the second power here. And when we do something to the second power, we get a U shape, what's also known as a parabola. Typically, the U is going to be facing up. That's facing up because this a, the coefficient in front of the x squared, is positive. If there was a negative sign in front, like you'll see with some of your work that I'm asking you to do this week, then the U will be opening upside down, so it would be flipped going from the bottom. So talking about some of these vocabulary words, axis symmetry is something that we dealt with last week. You can tell in this graph here, the axis symmetry is a red line that's going straight up and down here. So it's going to divide the graph in half. It's going to divide it into a left side and a right side. So as we're trying to find the information from the graph, that information here is going to be this dotted line where the bottom vertex is here, and that's called the minimum because the vertex is going to be at the bottom. That's going to be at x equals 2. So the axis of symmetry in this problem is going to be x is going to be equal to 2. That's the line that you can draw top to bottom that's going to divide this U-shaped parabola in half. Vertex, if it is a U shape like this, the minimum, since it's the bottom, is the vertex. That's what it's called here. If the shape of the parabola was the opposite, upside down, that means again that the a is going to be negative. So you could start something, maybe it's negative 4x squared. If that number in front of the x squared is negative, again, that means that the u is going to be flipped. It's going to be upside down. So wherever that vertex is in this one, if you were to draw that line, that axis of symmetry again, that's now, this vertex is now going to be called the maximum since it's the highest that this u goes. This, since the u opens up, this vertex is known as the minimum since it is at the bottom of the u. So for this one then, for the vertex, it's actually going to be an ordered pair. So remember, for our ordered pairs, we're going to put our parentheses around. And we already said the x comes first. The x is at 2, so it's going to be 2, comma, and now we need our y value. This dot below the origin is at -1, -2, -3, -4, -5. So that dot where the bottom part of this U is going to be, its vertex is located at 2, -5, which would also be known as that's quadrant number 4. The x-intercepts, that's stuff we've actually done if you were to solve the equation. It's the numbers that we solved for yesterday, or that we solved for last week. Um, X-intercepts are also known as the solutions. So if someone says, what are the solutions of the graph? If someone says, what are the zeros of the graph or the roots? Those are the things that they're talking about. So we notice in this one here, there's actually two x-intercepts that we're looking for. This graph is going to cross the x-axis at two different points. This yellow dot represents the first one. So that number would be at -1 since it's 1 to the left. So one of the solutions would be -1. And then this yellow dot here represents the second x-intercept because this u is going to cross the x at two different spots. And that happens to be a +1, +2, +3. So since it crosses the x at two different spots, it's actually going to have two x-intercepts. First one's at -1, second one's at +3. Y-intercept is the same idea, except the y now is the one again that goes up and down the y-intercept. So we need to find the dot where this parabola, this curve, crosses the y. It crosses below 0, and it crosses at 1, 2, 3 below 0. And since it's below 0, it's going to be negative. So that's going to be -3. So it crosses the y at -3. The last two ideas that we have here are domain and range. We have not talked about these this year at all. Domain is whatever the x values can be, the things that the x can be. So the x goes this way. So depending on how high this curve goes, this curve could really extend anywhere to the left, and as it continues to extend up, it could really extend anywhere to the right. So that means x can really be all numbers that you can come up with. So we're going to write all numbers. I'm just going to abbreviate that to save some time. It's going to be all numbers. That's going to be different when we find the range. Range is now going to be the values that y can be. So we talked about that this vertex is the minimum, which means there's nothing that's going to go below here. Everything is going to go above this. So what that means is the lowest number, the smallest number that the range, the y can be, as we determined earlier, is -1, -2, -3, -4, -5. Never will anything go below -5. I'm going to start at -5, and I'm just going to indicate really that it can be all other numbers. So -4 would come next, -3 would come next. So for right now, we're just going to say this, that it can be -5 and really all numbers that are bigger than that. And really, if we're being technical, we should probably say that since it's the y, that we're going to have y here. And y really can not, it can be -5. So y is going to be more than or equal to -5. -5. There we go. So it could be equal to -5. It is actually right here. And then any other number that's bigger than -5 is what it could be too. It cannot be anything less than -5. So really that's how we'd notate it. But this is also showing us it can be -5, -4, -3. Any numbers getting bigger, but it cannot be any numbers getting smaller.